we observe something better. You see light is being focused at this point here. Light is focused, and even if we use something like this, you see really that light is focused here. So different kind of rays coming, two different rays coming out, but they are being converged. As you go forward, they are brought together. At this point, which is the focal point, they actually converge together. So this is one interesting application. A converging lens converges two beams of laser together at this point. So now we're already talking about optics and photonics here. What if we utilize another type of converging lens like this one? Again, you see, with this one, it's also a converging lens, but it has a little bit more flat surface, and you can see what is happening. It is actually converging light at this point. So already we could use our laser source to basically observe how light is converged by a converging lens. This is another very interesting thing that we can see with laser light and with lenses. So with lenses, they could actually direct light in a particular direction, either focus it or diverge it. For example, this is a very complex diverging lens, and if I put it here, you can see how it affects light. You see there is a certain kind of light that is focused internally on the inside part, but also if you look carefully, light is in a way diverging. Let's increase darkness in a way, so you can see clearly, you can see very well that light is focused on the internal side of it, but also at the output there is light that is escaping. Let me look for something that might show us, enable us to observe this. Let's see. Yeah, you can see now that really it is, you see the beams or the rays of light coming out. As you move away from the lens, the distance and the separation between these two rays, keeps increasing as you go further. So you start here, they are very close to each other. As you move further away, the separation between these two different rays keeps increasing. So the lens is diverging light. Let's go again and observe another interesting phenomenon here. Like now, I'll use this glass slab, put it here. So let's say I put it straight like this. What you already see here, you see refraction of light. So light comes in a straight line, but then it's bent as it gets out of this. Why? Because these surfaces are different. This is at a certain angle, this surface is straight. So light gets out at a certain angle. Yes. I think you can observe. Light, in a way, is being confined inside this. Let's bring it closer. Turn it this way. And then bring it closer. Turn it this way and bring it closer. If you look carefully, you can see that light is bent from within. light is actually bent from within. You can see that the beam comes, it's reflected internally. This beam also comes and it's reflected internally. That's why at the end, you see actually where the beams emerge from. So, light has not been allowed to go forward on this direction. You see nothing. It has been bent internally. And this is very interesting principle because it's one of the main principles that is used in fiber optics communication. Total internal reflection. Light is reflected from within the glass.